Welcome to lesson 5.1 on monomials. Apply properties of exponents to multiply and divide monomials and convert between scientific notation and standard notation and multiply in scientific notation. So here are a list of monomials. That means that there's just one term. That means that there's no terms being added and subtracted together to form a polynomial. Okay. So just one term at a time, and they can have variables, 2 variables, 3 variables, okay, just one variable, or no variables, and fractions, and all sorts of good stuff, powers. These are not monomials, though. When you divide by a variable, when you're square rooting or cube rooting or doing any rooting, when you have two terms, when you have a variable to a negative power. So monomials cannot contain variables in the denominator, variables with exponents that are negative, or variables under radicals. Okay, so let's break down some terms here. A coefficient is the multiplier in front of a variable. The power is the value that it's being raised to. If it's x to the third, that means x times x times x. And these are all called bases. Okay, the last one without any variable is called a constant. Okay, sorry, let me just go back to bases for a sec. So like the 4 is a base, the x is a base, and to the power of 3, 3 is not a base then. Bases you can kind of think of as sitting on the bottom. Okay, so as if this is like all on a shelf, those are not on the shelf, okay? But the 4, the x, the 3, the x, and the 10 are all sitting on that shelf. Okay, properties of exponents. The power product. The power property. That means that if you take a to the m times a to the n, that's the same as the sum of the powers. And then the power of a power means to take a to the m to the n, means that you're going to multiply those powers. And if you have a product to a power, then that power distributes to both the values in that product. If you have a negative exponent, that means you have to sink that term below the vinculum. Also, if you had a negative exponent in the denominator, that would mean you'd have to fly it above the vinculum. So essentially a negative exponent just means it has to be passed onto the other side of the vinculum. So this is technically over 1, and it had to be sunk under the vinculum. And then we need a 1 placeholder on the top. A quotient of powers means to divide powers. M over n is to subtract them. But if you have the division of 2 bases to the m power, that can distribute to both those bases. Okay, remember that 8 to the third really means 8 times 8 times 8. Therefore, 2 to the 6 means 6 2's. And something to the 0 power, therefore, is just the coefficient of 1 as like a placeholder. Okay, so simplify these expressions using the properties. So I'm going to take 2 bases and divide them. In that case, I don't quite divide the exponents. I do something a little bit simpler. Instead of dividing the bases, but instead of dividing the exponents, I actually subtract them. So I'm going to go to the division of the bases, and 9 minus 4 is really what I'm thinking there. So you don't always have to write this out, but that's really the thought process. X to the 9 minus 4, that's x to the 5th. Okay, here I have 2 bases and I'm multiplying, and when I multiply like bases, I add the exponents. So 5 and 4 is going to give me 9. When you have an exponent to an exponent, then you're going to multiply those exponents. So 2 times 7 is t to the 2 times 7 equals t to the 14th. And x to the negative power, that's this property, it has to be sunk below the vinculum and with a 1 placeholder. So that's 1 over x to the third, where x to the negative third is saying sink me under that vinculum. Okay, next one, anything to the 0 power. This is the last property. No, it's not. It's this property. Anything to the 0 power is just the coefficient of 1, or a constant of 1. I like to call it a coefficient though, because normally there's more terms around, and so that part will just become a 1 multiplier. Okay, xy to the 5th, that's right here. ab to the m, what did we do? Both terms got a power of m, so in a way it distributed to the a and the b. So that is equal to x to the 5th, y to the 5th. And anything to the first power is itself. And then we have powers to a power again, that's like this property. What did we do? We multiplied. So 2 times negative 2 is h to the negative fourth, but we're not done yet. We cannot leave a negative exponent in our answer. So I have to go 1 over h to the fourth. Okay, so those properties have to become commonplace for you. Okay, and here's a little bit about those other properties. 5 squared means 5 times 5. 5d squared, though, the d is the only part that's being squared. Negative 5 squared means a negative times a 5 times a 5, which is negative 25. But negative included in the parentheses means that the negative gets squared too, so there's 2 negatives. So if the negative is not in the parentheses, then it's only the 5 that's getting squared, not the negative. Crazy, huh? Negative 5 squared is negative 5 times 5, negative 25. That's always a shocker. Okay? All right, but when the negative's included, then the negative gets squared. All right, 5y squared z is just that, but just there's only 2 y's. Everything else is just a singleton. Okay, so let's try to understand some of this. I'm going to take a monomial times another monomial. In this case, all the bases combine. So 3 times negative 4 gets me negative 12. Sorry, the like bases combine. X to the third times x squared. What we're going to do is we're going to add the exponents then. 3 plus 2 is 5. And the reason why is because of something like this. Anything to the 5th power is each part to the 5th power. Sorry, maybe that's not the right example. But x times x would be x squared. So x times x times x is x to the third, to the 4th, to the 5th. So right here, I technically have 3 x's, and here I technically have 2 x's. So altogether, how many x's do I have multiplying together? If I look at the expansion, 3 over there, 2 over there, I have 5 total x's. Okay, let's work with the y's. 2 and 4 gets me y to the 6, because I have y, and over here I have 4 y's. So 2 y's and 4 y's gets me 6 y's multiplying together. And that's what the exponent stands for. We have this many of those multiplying together. Okay, number 10. Negative 2 divides by 1. So that just gives us negative 2. X to the third over x to the second. In expanded form, that really looks like this. And we would cancel 1 for 1. In exponent form, using exponent shortcuts, we're going to take, instead of dividing, we're going to subtract the exponents. 3 minus 2 is just 1. And 5 minus 3 is 2. Okay, cubing the whole quantity. One thing I might do first is just do some reductions on the inside. I know, for example, y divided by y goes away. 3/9 is 1/3. And 2 of these will go away with 2 of those. So I really have 1 over 3x squared to the third. That's a lot less to bring to the third power. Okay, so 1 times 1 times 1 gets me just 1. And 3 to the third gets me 27. And x times x 3 times is 6 x's. Or 3 times 2 gets you 6. Bring your 3 to the third power, that's 27. That's because 3 times 3 times 3 gets you 27, because 3 times 3 gets you 9. 9 times 3 gets you 27. Okay, all of this to the 0 power. Remember that anything to the 0 power is 1. All right. You try the next set on your own and see if you can come up with some good answers. You can pause this video and I'll start going over it in just a second. Okay, so when we multiply like bases, we add the exponents. So 12 plus negative 4 is 8, and 6 and 8 is 14. I subtract the exponents, so I get b to the 6. I multiply the exponents, I get a to the 20th. It's not the subtraction or the multiplication that's the hard part. It's remembering what to do. And that comes down to you guys. Okay. X to the negative second times y, and x to the fourth y to the negative 1. Let's reduce. I'm subtracting when I divide like bases. I'm subtracting the exponents. So negative 2 minus 4 is negative 6. And y to the first minus negative 1. 1 minus negative 1 is a plus 1, and we get 2. Since this exponent has a negative, then it needs to be sunk. So we get y squared over x to the 6. I don't know why I did that line right there. Okay. All right. Number 5, everything's being brought to the negative 1 power. What I might do first is just reduce on the inside. 2 minus negative 3, minusing because I'm dividing like bases, therefore I subtract the exponents. 2 plus 3 is 5, so I have a to the 5th, and 1 minus 2 is negative 1. And all of that to the negative 1 power. The negative 1 power, you can think of it as distributing to both of these. So we have a to the negative 5th, b to the positive 1st. And then I can't leave that as my final answer. I need to sink the a to the negative 5th. So I get b over a to the 5th. All right, number 6. Everything needs to be squared. I'm going to do the same thing again. Reduce these first and those. So 2 minus 1 is 1. 1 minus 3 is negative 2. All that to the second power gives me x squared, y to the negative 4th. But I'm going to sink it right now and call it y to the 4th, and then I'm done with the problem. Okay. In scientific notation, we know that every time 10 is brought to a higher value, that there's one more 0 added. So if it's 10 to the first, there's actually 1 0. If there's 10 squared, there's 2 zeros. And if there's 10 to the 5th, then there's 5 zeros. So we know that as the power gets bigger, that the value gets much bigger. Okay, by a decimal place every time. A number expressed in the form a times 10 to the n is in scientific notation. So express 46 million in scientific notation. So how many 10s were there? 3, 6, and one more. 4.6 times 10 to the 7th. 3 zeros, 6 zeros, and one more. We always want to make sure that there is only one digit in the ones place, and that all the rest of the digits are after a decimal. Okay? And then you count how many decimal places you moved to make this to that power. Okay, now I'm going to come back to this idea. So skip for now. Okay, express each number in scientific notation. 24,300, move it 3 places and one more. 2.43 times 10 to the 4th. Okay. Over here, I want to move it 1, 2, 3, 4. 9.9 gives me one value in the ones place than all the other places, or just one more place. Okay, so 9.9 times 10 to the 4th. Oh, negative 4th, because I went into and made a very small number into a real number. Now remember, negative exponents means sink me. So that's really saying I have 1 over 9.9 times 10 to the 4th, which is really the same as saying 1 over 99000. Okay, 1 over 99,000. That's the same as that number right there. 199 1,000th. Okay. All right. Number 3 is a large number. 1, 2, 3, 4, 5, 6. Move it 6 decimal places. 4.86 times 10 to the 6th. Number 4 is a large number. 1, 2, 3, 4, 5, 6, 7, 8. And this is a small number. 1, 2, 3, 4, 5, 6. Okay, and a large number. Oops, -6. 1, 2, 3, 4, 5. Okay, so 2.21 times 10 to the 5th. All right, now multiplying and dividing numbers in scientific notation, we can do this by hand. 4 times 2 is 8 times 10 to the, when you multiply like basis, you add the exponents, or you can do it using the calculator. And that uses this caret key to get 10 to a power, times 3 times 10 to the 6. Okay, and then that is 68100, or 1, 2, 3, 4, to the 4th, 6.81 times 10 to the 4th. Or you can even go into mode. Oh, there it is. Okay, and then try to type that again by hitting second entry, hit enter, and 6.81 times 10 to the 4th. That's what that E means. Okay, times 10 to the 4th. All right, so try the next one. Over here on the calculator, we have this EE in blue right above the comma. Okay, so 9.5 E7 divided by 3.8 E -2. And that's 2.5 times 10 to the 9th power. Just make sure that you don't write in the letter E, but that you write times 10 to the 9th. All right, 1.62 E -2 divided by 1.8 E5. 9 times 10 to the -8th. And 4.81 E8 divided by 6.5 E4. 7.4 times 10 to the 3rd, and you get the idea. All right. After the Sun, the next closest star to Earth is Alpha Centauri C, which is about 4 times 10 to the 16 meters away. How long does it take light from Alpha Centauri C to reach Earth if it travels at a speed of 3 times 10 to the 8 meters per second? It takes it 1.33 times 10 to the 8 seconds. Okay, thanks for joining.